Calculus AB, December 7th, Wednesday, December 7th. In particular, we're talking about graphs of functions and their derivatives, okay? So a portion of a graph which is concave down and increasing looks like this. And it's going to look like that. Right? It's like half of like a thing, but it's increasing. It's like half of a dome. Okay? A portion of a graph which is concave up and decreasing looks like this. It's concave up and decreasing. It's going to look like here we go. Yeah. And then a portion of a graph which is concave down and decreasing looks like this. Okay.
The old man in their name is Mr. Myers?
Mr. Meyer.
Wait, he always been there?
No, he's first year teacher. Did Willow give you flat?
He's new?
Yeah.
Oh.
Every time I walk in there, Mr. Roscoe, are you supposed to be in class? Don't worry about the arrows. Just worry about like the shape.
Mr. Roscoe, did you find my test?
No, I didn't.
You might have it in your backpack. Where is it?
Well, he just said, I'm just trying to
Man, I literally walked in last. I know. And actually, it appeared before you. Yeah, it did.
No, it didn't. It was literally funny. Trust me. I was there.
That's fair. He was there. He was there. Richard's only been showered for some reason.
I don't know. I don't think it's someone.
I was there.
because there's no way it's last.
I'm not there.
Oh, the entire bridge. It's definitely something else.
Why would I visit your
No, they don't.
Oh, I thought you meant like after
That's the punchline. That's all I'm saying.
It
Okay?
doesn't even do anything. Crap, it's too late.
He's
Yeah.
making a
Don't worry about it. Don't worry. Yeah.
I don't care.
Okay, I'm gonna get rid of that hair. Okay, it's really throwing me. But don't like. This is just the shape. This is. I'm still getting to the punchline here.
What?
Okay.
Richard was distracting me, so.
All right, guys. I figured out a good way to teach this. I think. Okay. Figured out a good way to take the critical thought out of it. Okay, so you guys don't have to think. Just like high schoolers love these days.
Great. I love you.
Okay. You don't have like axe or something. Yeah. You know what?
Oh, I do. I have not asked.
They don't have asthma.
I've seen
Yeah.
It's from the vent, yeah.
It's so bad.
James down, close it down.
town.
Ooh, differential equations textbook.
We turn off the vents.
Open this up.
What's that deodorant?
It's not good though. There's none less sprayable.
It's like Morrison.
It is the register. Oh gosh, it smells horrible.
Can we like go outside?
Someone help me. Give me
No, but you come with it. Yeah.
Here, I'll put them on. You go to. I can't believe you blame me for that fart. That's literally.
That's something you do. Like, that's
Smells
something
like-
I want you here and then you blame it on me, so. Yeah.
you would fart and then
No, I would own up to that. If that was me, I'd be proud
Is
of
that
that.
it? Okay, and then we'll put
I literally was
take
in the
this bottle
bathroom.
full of like
Exactly.
a little
I got assaulted by a freshman.
whiff.
He said he was gonna come to my house right
We'll just put it there. Maybe like it'll just like.
It's like getting into my mouth. It's still gonna go
like
through
close
the
your
crowd.
mouth.
Taste it. Let's take a bunch of these out and just lay it. Hopefully it'll like blow.
Campbell. How are you gonna put it here?
It's on the bottom too. Is it?
Oh, wait, that's
That's not fire.
no!
What am I supposed to do? What am I supposed to do?
That's something
I
that's
just never
smoked
said
flat.
that.
How am I supposed to learn this part?
Okay, that's a lot better.
Well, I was like, 48 hours is still on. Like, I
Guys, come on.
I didn't say, oh, 48 hours, yes.
This
This
is
last
basically. Where I put my iPad?
48 hours.
Try to put it on the
Tyler,
table.
Yeah, that's a great question.
Can I do that on your desk?
Oh, look at the pun.
Got my fingerprints all over it. Okay.
Yeah, I'm moving over the other side around.
It's making it better.
Okay, guys. So I figured out how to teach these pretty well. Okay. I think.
Y'all
Yeah,
are
you guys
so
can move.
driving.
You don't understand how bad it is.
Okay. Thank you.
Wow.
Smells good. Is that Randy Melville?
I even make this.
Is it olive oil for
So
you?
it's a Tuesday, 48-hour job.
Hey, Tony.
Ava believes that if you put it on your No. One time I had Zach's tutor who was the 48 hours Versace, and I was like, wow, it must have been 48 hours still on. And then they thought that I just wear deodorant once She like believes in lies.
All right. All right. So I figured out a decent way to label these graphs. Okay. Let's get it going. All right. So first off, we're going to talk about so the three things we need to get right. Okay. We're looking at the graph of f prime. It's going to tell us about the concavity of f, whether f is increasing or decreasing, the relatives mins and maxes. Okay. So first, let's plot the concavity. So what I'm going to do here is I'm going to take my dark green pen. Okay. I'm going to make it dashed. Okay. And I'm going to draw a vertical line through the part of my f prime graph where the concavity of f changes, okay? So concave up, f of x is concave up where f of prime is doing what? Increasing, right? So where's f prime increasing?
Negative infinity to 0.
Right? So it's increasing to the left here, right? And it starts decreasing after this point. So I'm going to draw a vertical line. Green vertical line through there, okay? Right, so to the left here, f is concave up, and to the right, f is concave down, okay? All right. There you go. Now, I'm going to use a red dashed line in the spirit of Christmas. Okay, I'm going to write where f is increasing and decreasing, okay? So when f of x is increasing, what's true about f prime of x?
It's
Positive, right? It's positive. The graph is above the x-axis, right? Is that true for anywhere here?
No.
It's always doing what?
Decrease.
It's always negative, right? So it's always decreasing except where?
0.
0, yeah. 0, okay? So I'm going to use my orange pen. And I'm going to mark that one point here. That's going to be my critical point, right? I'm going to have a critical point everywhere f prime touches the x-axis, okay? So I'm going to mark it.
What were you saying that was decreasing?
F of x is decreasing. All right. All right. Okay, what kind of critical point does f have here? What kind of critical point? Goes from negative to negative, so it's a point of inflection. The sign, it touches 0, but the sign does not change, okay? Okay. Okay, so the first thing, so now we're ready to plot f of x, okay? First, in pink, we want to plot any given point. So that's like a problem like down here, passing through negative 4, 2, okay? So there's no given point right here, right? Because it doesn't give us a point that the graph passes through, okay? So we don't need to worry about that. But what I'm going to do is I'm just going to take all these vertical lines I drew over here and copy them right onto the f of x graph, okay? So I'm going to draw a green vertical dashed line through the y-axis over here, okay? And again, to the left, I know f of x is going to be up, concave up. To the right, it's going to be concave down, okay? And then, this is kind of not the best example, but I know it's decreasing everywhere. I know it's decreasing everywhere, okay?
How do you not create the same graph?
I'll show you guys how to do that, okay? So to the left here, to this in this region, right? This graph here, right, is going to be split into 2 regions, okay? Because there's one vertical line, so there's 2 regions, okay? Are we following? Okay. So to the left here, I've got to draw a curve which is concave up and decreasing. Oh, that's this one, okay? So I'm going to draw a curve which is concave up. Just going to copy that right onto there. Okay? To the right, I need to draw what? I need to draw a curve which is concave down and decreasing. Let's go over here. Concave down and decreasing looks like this, okay? So I'm just going to draw that little, okay?
Mr. Rusk, I bet you were excited when you figured this out.
Look, no critical thought. Yeah, I literally just copied and pasted. Literally just labeled the different regions, copied, pasted. Boom. We're done. That's it. That's it.
Can we use the board on the test?
What?
Can we use the
Because
board
it
on the
makes
test?
sense.
It's such a great idea.
All right, now let's go to the next one, okay? Oh, spoiler alert.
Wait, quick question. How did you come up with those over there though?
With these
No, on the board.
on the board.
Yeah, like how did you come up?
So concave up and increasing, that means that F is increasing, but it's increasing at an increasing rate. So it's going to be growing really faster and faster. So it's going to be growing. Same here, concave down. Increasing means F is increasing, but it's increasing at a decreasing rate. So it's increasing, but it starts to level off. Same, concave up, decreasing. Okay, it's decreasing, but at like a slower rate. It's here it decreases, but at an ever faster rate. It starts to really drop off. Okay. Good question. All right, so let's do this one. Let's do this one, okay? So let's label the concavity first on my F prime graph, okay? So we're going to split this graph up into where F prime is increasing. Okay, so F prime is increasing, then it stops, and then it starts decreasing. So it gets to here, right? We're decreasing, boom, okay? And then we start increasing again. Okay, so we're increasing, and we're always increasing, okay? So it's concave up here, it's concave down in the middle, and it's concave up on the left, okay? Okay, now let's label where F, actually let's copy that down. Now let's copy this exact set of lines over here, okay? So let's draw a vertical line through -3. Okay, let's draw a vertical line through +1. Okay, and then we're going to write up, down, up. Okay, so that's the concavity. That's where f of x changes concavity, okay? Now let's use I'm going to use my red pen, okay? I'm going to mark all the places where f changes from increasing to decreasing, okay? So where's that? So it changes from negative, so it's f is decreasing, right? Because f prime's negative. Then when I hit here, f starts increasing because the f prime of x becomes positive. So we're just gonna, I'm basically drawing a vertical red line through wherever f prime hits the x-axis.
Are we figuring out the critical points? Or?
Yeah. The critical points as well as whether f increases or decreases. Good question. Good question, Blair. Good. Okay. So we know in this region we're decreasing, f is decreasing. In this middle region, f is increasing. Then we're decreasing again over here. And then we're increasing again over here. So I'm just going to copy these 3 vertical lines down over here, okay? So red vertical line through -4, okay, in the spirit of Christmas. Okay. Red vertical line through -2. Red vertical line through +4. Okay, this is what we do in my Algebra 2 class. We use our highlighters and our colored pencils. Okay. All right, so we're decreasing. We're just going to copy these down, okay? We're just copy them onto the f of x graph. Decreasing, then increasing, and then decreasing, and then increasing. Okay.
Wait, I thought we already figured out increasing and decreasing on the f prime of x.
That was concavity. Okay. we looked at whether f prime was increasing or decreasing. That tells us about the concavity of f of x. Okay. We looked at the sign of f prime of x. That tells us whether f of x is increasing or decreasing.
And then we use that.
All right. So now I'm going to use orange. I'm going to use orange, an orange solid pen. I'm going to label my critical point. So there's going to be a critical point on f of x at every single red line here. Okay? We just got to figure out which type. Which type, okay? And actually, I'm going to use pink for that first one, right? Because the given point is -4, 2, right? So we just need to plot -4, 2. So let's plot that pink point here. All right, and that pink point, is that going to be a max or a min or a point of inflection? How do we know?
Min, because it goes from negative.
Yeah, so at -4, f prime is changing from negative to positive. Okay, that means we're going to have a min there. Okay, means we're going to have a min. All right, so this is going to be a min. Okay. Then let's plot the critical point on that second red line. Okay, and the second red line, what kind of critical point are we going to have? F prime is changing from positive to negative, so it's going to be a what? Max. So let's just make that a little higher than the pink point.
Wait, where did you get that from?
First derivative test. F prime changes from positive to negative, right? What kind of critical point is that? That's relative maximum. Yep, and then over here on this line, what's f prime doing? It's changing from negative to positive, so it's going to be another min, right?
It doesn't matter where you put the max, though, right?
No, just just put it above the. Just make sure they're staggered. We should go from min up to max, down to min. Okay, you shouldn't go like up to a minimum. Okay. Good. All right. So now we're split into what? 1, 2, 3, 4, 5, 6 regions. Okay. So let's start over here. Over here we have to draw a decreasing concave up curve. Decreasing concave up. There we go. So it needs to look like this. So it's going to go.
With the sound effects? Yes.
Yes. Okay. And here we're going to be concave up increasing. Okay. So I'm going to be curving up, and then I hit that green border here. Now I've got to be concave down increasing. What's that look like? Concave down increasing it. Okay. So it's got to start doing that. It's got to start like bending, like S, like looking like an S. Okay, now in this region, right, f of x is decreasing and it's concave down. So it's going to look like a guy diving off a board, or a gal. It's going to be decreasing, concave down. Okay, we hit that green region. Now we've got to switch to concave up. We're still decreasing. We need to be decreasing, concave up. What's that? Decreasing, concave up. Like this. There we go. And now we're concave up, increasing, which looks on the board. We look at the board, it looks like this. That's it. We're done.
Wow.
See, that was
What? It was a lot, but it was step by step.
I like that. How did the min on the right?
Yeah.
How did we figure out that was that large?
It didn't need to be. It just needed to be below here. We could have done it right here, but I feel like it's easier to draw the graph and you exaggerate it.
Okay.
It's any possible. It just the only point that needs to be where it is that pink one, because it says passing through -4, 2.
But so doesn't matter your y values, it just matters your x values.
Yeah.
So
And like the shape of the curve in the different regions.
Well, you can have different size graphs and then those different.
Yeah, they're yeah. So not every possible graph you could draw is right, but there are many possible graphs. Yeah.
Why is it decreasing from negative infinity to
To
negative?
-4. Because f prime is negative in that region.
Oh, okay.
Yeah. So a lot better than yesterday. Okay. Okay. So this notes is actually your homework. So the more notes we get through, the less homework you have. So. Yeah.
Oh, that's.
Awkward.
Do like a hard one?
Yeah, you want to do a hard one?
Like I or
They're all so easy. Though. I'm kidding.
Wait, like the rest of it's like a video now?
No, you're just gonna do the rest. Whatever we don't finish, you're just gonna do
Can
homework.
you do like
What?
I?
But we don't know how to do it.
You want to do I? Well, yeah. So we're gonna do as many as we can together.
Yeah, let's do I.
You guys want to do I?
Yeah.
All right. Easy money. Super easy. All right. So let's mark the concavity.
What's the dimension?
Let's mark the concavity on f prime of x. Let's mark the concavity. Okay. So here we're decreasing. F prime is decreasing. Okay. So up until this asymptote here, we're going to be concave down. Okay. And then to the right of this green line, right? What's f prime doing to the right of the green line? Getting taller. It's increasing.
See, okay. You mean concave up. Okay. When you say increase and decrease, I'm thinking you're talking about.
I'm looking at f prime's doing.
And then from
But you're just looking at the concavity. Correct.
Yeah. Right now I am. Yep. So then we're just going to take this and we're going to copy it over on the f of x box. Okay. Okay. So we're down to the left.
Down. Up.
That's really dark outside.
Not even 3 o'clock.
Passed out of time and space. Darkness
Star, what a like the. Is that a Star Trek reference?
of the Lord of the Rings.
Oh, not Star Trek.
Alright.
I've never seen Star Trek.
Alright, let's label whether whether f of x is increasing or decreasing. Okay? So f of x is positive, then we boom. Critical point right there.
Boom.
Okay? What kind of critical point is that? So f of x to the left here, right? It's positive.
No, negative.
So we're increasing, and then to the right of this, we're decreasing, right? Okay. Increasing to decreasing, that's what kind of critical point?
wait, increasing, decreasing, maximum. Is it maximum?
Yeah. Okay. Right, where am I going to draw my next red line?
And do we know it's
3.
increasing based off of the
Sign. We know whether f of x is increasing or decreasing based on the sign of f prime.
Oh, okay.
Yeah. Okay, so then I'm going to draw my next red line at 3. Okay. So it's going to be increasing after that second red line. Okay. What kind of critical point am I going to have here?
Minimum. Minimum.
Yeah, be a minimum.
Not.
Yeah, it goes from decreasing, yes, it's a min. Okay. And then what kind of critical point am I going to have on my asymptote here?
Point of inflection. No. No, it's. And what is it? It's asymptote.
Oh, you're asking.
It'd be a point of inflection, wouldn't it?
Oh, no.
Yeah, because it's the same sign on
Boom.
both sides.
Boom. What? I said it's not.
Right?
He said asymptote. He said it would be a point of inflection. Is that not an asymptote?
Actually, don't worry about that. I think it'll be actually be an asymptote on the graph too.
Okay, wait.
He said I was.
It's on.
He said I was right. Second.
Why is to the right? It's
What's on? Because that's where the F prime.
Why is it increasing over here? Because f prime is positive. F prime is positive, so f is going to be increasing.
okay. So we're just looking at. Okay, so we're not looking at when it goes from positive to negative. That's not. That's like.
That's to classify the
next-
critical point.
Oh, okay.
And I'm just going to copy that asymptote over here, guys. Which I already did, I guess. Okay. So now let's graph. Are there any given points we have to plot?
No.
No. Okay, so we're going to have a max. We're going to have a max right here. Okay, so let's just draw. So, oh wait, we got to copy the red stuff. Sorry, I forgot. Jumping ahead of myself. So we're going to have a max on this red line, okay? So let's just draw an orange dot like really high up. Might as well. We're going to have a min on this red line, right? So let's just draw an orange dot like really far down. Might as well. Okay. Now we're ready to draw in our answer, right? So to the left of this red line, we're concave down increasing. Okay, so we're going to draw something like this, okay? Put an arrow on the end. Now in the next region, we're concave down decreasing. What does that look like? It looks like this, okay? We got to approach that asymptotically too. It's just going to look like this. Concave down decreasing. It's concave down decreasing.
Oh wait, so we don't.
Well, so there's an asymptote there, so it's got to approach the asymptote. Okay, the next region, we're concave up and decreasing. Okay, concave up, decreasing. Yeah, it's the one that looks like an L. But it's got to approach that asymptote asymptotically. So it's a really skinny L. And then to the right here, we're concave up, increasing. Okay.
Can you go to the original?
The F prime.
Yeah. Wait, so how do you know between the max and the min that it was concave up?
Between the max and min, it's not. It switches concavity here. So here's the max. Okay. F prime is decreasing here. It's decreasing. Wherever it's decreasing, we're going to write concave down. Okay? Wherever F prime is increasing, we're going to write concave up.
Yeah, but how about in between? Is there concavity or no?
No. So there is concavity. It just changes at this, like this in between region. Like half of it's down, half of it's up. Yeah.
Oh, okay.
Yeah. Yeah, and then again, this is all possible f of x. What's kind of arbitrary here, especially because there's no given point. We can slide it. We can slide either of these up and down. All right, Tyler.
Answer my question.
Okay.
I was wondering why, like.
So like the answer key has like something a little different, but it's just this. They have it a little different. It's like this, but like they slid it these things. Like, up and down.
I was wondering why the minimum was so high.
Yeah.
You want to see my-
Or the maximum.
So I felt like it. Okay. There are 4 of those left. Let me show you how to do some of these other ones.
Like, I hate when people reach over my food.
All right, guys, let's go to 5-9 then. Let's do some of the 5-9ers.
Is 5-9 homework too?
Yeah. We got like 22 minutes, so we should, and I'm the teacher, so we should be able to get through this really fast. A lot of this. E. Now I'm gonna try F first, okay? So now, right now, instead of this is the same thing though, guys. Now just instead of let's look at this one, okay? We got all this information about f of x over here, right? Where did we get it from? We got it from this picture of f prime of x, right?
Yeah.
Now we're getting the information just from the words they give us, okay? So f prime of x is greater than 0 for all x. So what does that mean? We're increasing everywhere.
Increasing. Oh, wait, what?
We're increasing everywhere. That's what that first piece of information gives us. What's the second one? F double prime of x is greater than 0. What does that tell us? Concave up everywhere. Okay. And then we have to plot that f of 1 equals negative 2. What point is that?
1, negative 2.
1 comma negative 2. What?
2.
So we're concave up, increasing everywhere. So you just need to like copy one of these down. It's an exponential. Right? Say it's an exponential. Yeah, it is. Ha! Just gonna draw one of those. That's all we gotta do. Done. Easy money. Go home. Tell your parents you got an A.
Wait, really? We can go home? Oh, no.
Yeah, easy money, especially if you get
No.
jobs like an engineer or something.
Java?
Not that engineering's like other than but
No.
yeah.
Wait.
so-
Does that matter, like, in the graph, like, when it's like a cusp?
What's that?
It's like a sharp turn as a graph. Is that what?
Like for, okay.
Jay,
Yeah.
Wait, Mr. Resta, are you
we can do that one.
trying to be a professor?
Yeah, maybe. All right, Jay. So we can talk about Jay in a bit. Look, I got to show you guys how to do these, though. Okay. Okay. So f prime of x is greater than 0 for x greater than 1. Okay. So at this boundary, right? At this boundary, x greater than 1, I'm going to draw that vertical red line. Right? So what should I write to the left of this? Decreasing it. Dec. To the right, I'm going to write inc.
Wait, what?
Because it says it's decreasing.
Because it's less.
Where did you get the acetone from?
Where's less?
What's that?
Where did you get the acetone from?
Like this red line that I just drew?
Where'd you?
X greater than 1, x less than 1. So I drew vertical line at 1. To the left, I wrote decreasing. To the right, I wrote increasing.
Oh.
Okay? Okay, look at this. What's the concavity?
F prime of x is greater than 0.
F double prime of x is greater than 0. Okay, so it's concave up everywhere. And write up. Okay? Are there any given points I need to plot? 1, negative 1.
1.
And then it gives me the additional piece of information, which it really didn't need to, right? It gives me the additional piece of information, right, that f prime of 1 equals 0. Okay? So we know 1 is a critical point. What kind of critical point? If f's changing from decreasing to increasing. Min. Min. It's a min. So to the left here, we're going to be right. We're going to draw a curve that's decreasing and concave up. What does that look like? There we go. The L. Okay, and then to the right, we're going to draw a curve that's increasing and concave up. Increasing, concave up. Here we go. Okay. There we go.
What do we do with f prime of 1 equals 0?
You already did. You're done. That's it. It's gotta be good. All right. How we feel about this? All right. I'm going to do C. So there's 4 of these, and then 4 of these up here. What do you guys want to do? F? I think I just want to do J.
Yeah, let's do J.
Okay, J.
Yeah.
No, I meant F on this one.
Okay, we'll do J first. I got a request for J first. First, I got my request for J. Okay, so let's label this guy right here. Okay. All right. Let's do concavity. I like doing concavity first. I like green better than red. So. All right. So where am I going to draw this green line?
-2.
Negative.
Yes, right. So f prime is decreasing, decreasing, then it starts increasing. That's really cool. Okay. So to the left there, what am I going to write? Down or up? Down. To the right, I'm going to write what? Up. Yep. So let's copy that over here. We're just going to draw a green vertical line through -2. Alright, so we're going to write down and up. Alright, am I going to draw any red lines here?
No,
Nah.
because it's all up.
Right, it's always increasing, right? F prime is always positive, except for what? It's a critical point. Yeah, what are my critical points? Yep. So what kind of, right? So there's a critical point here, right? Because F prime touches 0, but it's positive on both sides. So what kind of critical point?
An inflection.
Point of inflection, yeah. We got that point of inflection going on. We'll just draw it right there. All right? So we're always increasing. So to the left here, we want to draw a curve that's concave down, increasing. Right, and to the right, we're going to draw a curve that's concave up, increasing. All right, sweet. This method helps me a lot too. There we go, that's it. That's so much better.
So how did you figure this out?
I was driving to Meyer yesterday to pick up my mom's prescription for her. And I was in the parking lot, and I was putting on my Spotify playlist, and I was like, wait, what if we did this? True story.
Wait, what's on your Spotify playlist?
What
do you listen to?
Do you have Christian rap like Levi?
Oh God, please
What?
How does that have anything?
All right,
Wait, what?
so I actually got to make sure she
Levi is not listening.
took her meds.
Okay, Levi is in ministry. Well, no, he did during when
All right, so let's do the rest of these. Let's work. Let me do one more down here. Let's do C.
Levi introduced me
Can
to
we do the one with the fraction?
Oh, you said F, right?
Yeah.
Can we do the one with the fraction? Scary.
That's what they do like every When he doesn't listen to Christian rap, this is like that.
This is a good one to go over. Okay.
Just one time I got big like
Cool.
music up there.
So let's see.
Yeah, maybe he does.
I mean, I like some of the songs. It wasn't Disney that bad, it's just
So there's one boundary line here.
At -2. I mean at 2.
Positive 2
Positive
wa.
2.
Yes. Positive 2 wa.
it came out of her.
Okay, so let's talk about the concavity. Let's talk about the concavity here. Start with my green. All right. So it says f double prime of x is less than 0 for x greater than 2. So we're going to write down over here. Okay. What's f double prime over here?
It's undefined.
That's a good question.
0.
So f prime of x, right? If it's increasing, f double prime is positive. If it's decreasing, f double prime is negative. What's it doing? What's f prime doing? It's staying the same, right? So what's f double prime? 0. Wow. So it doesn't have concavity. But we don't need to know that actually. We don't need to know the concavity here because we know what? It's got a slope of negative 1/2. So it's just going to look like a it's going to look like a negative slope line, okay?
So it's just a straight line.
So it's going to be decreasing, right? We know it's going to be decreasing over here and then increasing over here. So I think the red and green lines are on the same, they're in the same spot, right? Trying to draw a Christmas line in the spirit of Christmas.
Can you clarify what we look at when determining which is which?
Like for concavity, or do you want me to do like the red or the green? What do you want me to do?
Like everything. So like we look at f prime of 2 to determine the critical point. I mean f is 2 equals 0.
Yeah, so for that, we just got to plot that. You just got to plot that.
So that's a 4. So what does f prime of 2 tell us?
'Cause that doesn't.
We'll see. We'll see when we like draw our lines in. Okay. So I'm going a little off script. Okay, we're going off road. So sometimes you go rogue. We're going a little rogue here. Okay. Okay. So to the left here, right? This is actually pretty. It's a little different than what we've done all class, right? It's actually pretty easy though. We know to the left it has a slope of negative 1/2 and it hits this point. So I'm just going to draw a line with a slope of negative 1/2 here. Okay? So negative 1/2, that's going to be, there's going to be another point there. Okay? So to the left here, my graph just looks like this. So this, like, yeah, we're going a little off script here, like, in terms of what I've been telling you, but it's actually really easy. You could have done a problem like this, like in pre-cal or algebra 2. This is just saying, hey, draw me a line where the slope is negative 1/2 and it hits this point. That's like point slope form. Yeah, I could have done it since preschool. If you were me. I'm kidding. I couldn't do that in preschool. Couldn't do that in preschool. I swear I couldn't. I actually didn't go to preschool, so.
Whoa.
Neither.
Yeah. You said me neither?
Yeah.
Nice. Get on the road.
Did you learn?
Yeah, my mom taught me how to read.
Honestly, that's cool.
I couldn't like write my name, but I could read. So. I had no fine motor skills. All right. All right. And then to the right here, we got to be concave down. Oh, I hate that. We got to be concave down, increasing, right? Just like that. Now do you see f prime 2 does not exist?
Yes.
That's it, right? Is that? Which one did we just do?
It's not the flip.
Yeah, got it right. This method's awesome. All right, this makes it. Guys, I had no clue how to do that one. I just followed the instructions, and we got the right answer. All right, so let's do the rest on your own. Let's go. You got 8 minutes.
Just like not.
Yeah.
Is this homework?
Yeah, the rest of the notes is homework.
So my question is, I was saying, determine which one. What does it say? It's 7. So what? And then we look at these to find the asymptote. Correct.
That's to find where f is increasing or decreasing. So it says f prime is rated as positive to the right of this line. That means we're going to be increasing to the right of this line. So we're right there.
Oh, okay. So,
And then it says f prime is negative to the left of the line. So we're going to write dec or dec.
so this determines, these determine increasing or decreasing.
Yeah.
And what is, this is just the point, just the plot.
That's not a plot the point because f prime of 1 equals 0. The plot the point is right here.
So what does this show?
That shows you that there's a critical point at f prime of 1, which you already knew actually, right? Because you know that f changes from decreasing to increasing at this line right here. So you know there has to be what kind of critical point? F goes from decreasing
To,
relative it goes from decreasing to increasing.
What else could I possibly do?
Wait, so.
So you know there's a min right there.
People that drive slow in Fall
And
Creek.
then
People that.
this tells us.
The concavity.
What about where Santa has to school?
So how do we know that? Asymptote, just because we're.
That's not an asymptote. How do we know like this
Oh.
line? How do we know this line is here?
Yeah.
Because it says for x less than 0. It's just a border. It's a border between x and some separate for f increase and
I
decrease.
don't know,
Because
that's a
it's
freshman.
oh, just to separate
Copiers.
the increase. Okay, thank you.
Sweet.
I did a week.
Yeah.
I did
So spatial reasoning's not as good as my verbal
Private
reasoning.
selection is when it changes.
People that like math.
That's where it changes between
Honestly,
point of inflection is
people that
where
like English class.
f prime hits 0, but it doesn't change sign.
What
So it just like bounces off.
sin
at
is
x
like
axis. So there
whatever
is-
whatever sin I choose is gonna be under the ice.
Ow.
Sweet, awesome. Hey guys, good work tonight.
Okay, but
Yes.
why is? Or no, wait, no, whatever sin I choose is gonna be
Also, what did you saying
on
after?
time.